Morning, everyone. Start Unit 4 or Module 4, Arrays and Function. In first part, we will see the functions, and second part, we will discuss about array. Okay. So this unit consists of one-dimensional arrays, example of iterative program using arrays, 2D arrays used in matrix computation, concept of subprogramming function, example of user-defined function, function prototype, return value, and their types. Calling function, function argument, function with variable number of argument and recursion. So actually we can use it, means we can start um, arrays unit first and functional programming unit next. But I'm going to discuss this modular programming unit first because it is very important and we need to start from this functions only. Okay, so this is our part one and this is function. So introduction to function, program modules in C, math library function, functions, function definition. Main concept behind C programming is function only. Okay, like if you are going to write your program using C language, then you need to write main program first. Okay, and sometimes you need to pass the arguments also. So how, like in our command line or program, command line interface, here we have already seen that how do we pass the commands like argc and argv in previous lecture. Okay, so likewise we can create our own function, and this function, before going to explain any other function, let me start with fork function. Okay, fork function will create exact copy of a running program. So here you can see that only 3 or 4 lines are written. Fine. Like integer main. Integer main is your main program. And then fork, 3 times fork is written. You can execute with 2 times, 1 times, etc. So how do this program, this fork will create this main program? Actually, this fork will create exact same copy of this program. Okay. So how do you check what is the name of program? What is the name of program? What is the instance of program? Actually, it gives a simulation like the name of program is fork demo. Okay. If you are running this program, then these many spaces are coming and these many spaces are coming. These spaces says that we have started running this instance of program, then there are several other instances of other programs, and then again the main program will start running, means fork demo program will start running, and the process ID of each program is also shown. So before going to explain you this fork demo, let us see process ID. So this is our task manager program. Okay, if you click on this, then task manager will show you details of processes. So here you can see that one process with PID 0 is having highest priority and its CPU consumption is also very high. And the name of process is system idle process.
Sir,
Our main function,
Actually,
yes,
sir, we are
sir,
not
only
able
PPT
to
is visible.
see. Yeah, we're not
yes,
able to
yes,
see.
yes. Fine, fine. Now it is visible, I think. Okay,
Yes, sir.
so whenever you are running task manager, then task manager will show you. I had used with respect to process ID, increasing of order of process ID. So this process ID PID shows whenever system is idle. Okay, whenever system is not using anything, automatically processor will be occupied by this process. And each and every process is having unique process ID. Okay. If I want to run all these programs, actually this program is runnable in Unix portion only, and it is not able to run in maybe in GCC compiler for our let us start also code block, and if it is able to run, then I will show you. Otherwise, I am having the same program in Unix operating system also. So these are the process ID. You can see the process ID of each and every programs here, and these are unique. No two processes having same number. Although like Chrome is open, so Chrome is having this process number. Okay, and Microsoft Edge, yes. SVC host 5008 and 5020 process ID. Three processes are running SVC host, and more number of processes are there. Teams ID is also there. Okay, so this is all about process. Here you can see the services associated, and these services also having process IDs. Here it shows the users and associated programs. So you can see the number of tabs, number of Google Chromes are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Actually, 13 different Chrome programs are open. It shows, but it is not like that. Actually, each browser opens a particular program, like WhatsApp is open, and this Outlook is open. Okay, so I am opening this WhatsApp and this Outlook, and this Outlook is associated with several other programs like Notepad, Reminder, and some more programs are there. That's why these many number of Google Chromes are shown. Okay, so this is all about processes. Microsoft Edge to having, you are using team in three different windows. This is one window, okay, and this is another window, and one more window is there, but it is not shown here. So only three windows are there. But for this particular thing, one program is designed. Calendar, for calendar, one program is designed. For team, one program is designed. So it shows so many open means so many processes associated with Microsoft Teams as open. Okay, so this is all about process startup. At the time of startup, so many applications are automatically get started, and it takes a lot amount of memory. Okay, and then these are the process, and it shows the CPU time. If you are considering CPU time, then Microsoft Word whiteboard we have not used, but it is showing that it is open from last 54 minutes. Okay, why? Because Teams has already opened. Then this shows the performance, and so my task is, my major task is to show you that detail of process and process ID. Here you can see in this program also, it shows process ID, and for process ID we need to use get PID function. Okay, get PID will automatically execute the process, automatically fetch for the process number. So this fork means we are opening two number of fork demo program. Okay, program one, program one, program one. If two fork is called, then four number of processes will be called, four number of programs will be called. Then if three is there, then 2 to the power 3 means we are having 8 number of programs, copy of program. Okay, it is not executing this printf 8 times, it is executing this program 8 times. Okay, so the difference between both thing is, because if you are running this program, it shows that you are running printf so many times, but it is not like that. It runs the program so many times. Okay, so let me show you this program, and this will be very helpful in operating system class. So yes, If fork demo is there, then it is very good. Yes. Okay, so this says that undefined function fork for here. So it is not able to run this fork because it is only PHYSICS compatible. PHYSICS compatible. What is PHYSICS? I think you are not having this term before. You have never heard this term before. PHYSICS. Okay, it is written as POSIX but pronounced as PHYSICS because this system involves multiple phases of development. Okay, so it is written in standard documentation that do not pronounce it as POSIX or some other variation. Its pronunciation must be PHYSICS. Okay, so what is PHYSICS? This is portable operating system interface for Unix-like operating system. Okay, so this is not compatible with our PHYSICS, so that's why it is not able to run here. Let me open command prompt from Ubuntu, and I think here fork demo is there. Yes, so vi fork demo .c. You can see the same program, whatever written in code block also. So this is the same program, similar program, and I am running in compatible system with Unix. Now let us compile this program fork demo.c. Now this is compiled and you can see that so many errors are generated, warnings are generated, like implicit declaration of function for. Second, implicit declaration of function get PID, because these are the low level functions and directly associated with operating system. Fine. So that is the reason it is shown here, and only it shows warning, not error. Now let me run the program. Before running this program, let us clear the system and now run the program. This program clearly indicates that, what is the indication of this program? It says that up to this time, it runs some other program and then it runs fork demo. And after that, some other program will be run, and then fork demo again is coming into existence. Then the same thing, and then continuously it will run the fork demo program. You can see the IDs are also there. Process ID 34 executed first, 39 next, then 35, 40, 36, 38, 37, and 41. So this can be executed in random order. It is not necessary that process ID with lower number will execute first. Okay. Once again, I will show you. Here you can see that in previous pattern, the previous pattern is little bit different. Okay, so let me copy the pattern also. So this is previous pattern of program, and better to paste here. It is pasted here. Okay, and one more copy is so in both the copy, if the same program is running, then same set of printf must be run there. Okay, it is our assumption, but it is not like that. Here up to this place some gap is there, then again process will executed and then gap and then executed. So you can run different instances, it will run in different manner, because so many means thousands of programs are there which is in execution process. So whenever processor is free, it will given to the processor and then it will execute the program. So this is the use of fork. Okay, so I want to show the use of fork because in fourth semester itself you need this type of thing. Fine. And the process ID already shown that this is not hypothetical concept. It is each and every process is associated with a particular process number. So suppose that here this is 67, then 71, then 69, then 72, then 68, then 73, followed by 74, and finally 70. Okay, so these many process numbers are there, and each process says that different means each process number says that it is a different program. This is one copy of fork demo, this is another copy of fork demo, this is another copy of fork demo, and so on. So that's it for our fork function. Now come to next, modular programming. Okay, what is a function? So this is the actual unit. Now actual unit begins. So function uses divide and conquer strategy. What do you mean by divide and conquer? Divide and conquer means here you can see in bottom that there are two functions, cos x and sin x, and each is described by its expansion value. How do we expand the cos x and how do we expand the sin x? So it uses different set of functions like power. It uses power in numerator and factorial in denominator. Yes or no? Similarly, in this also, in sine series also the same set of functions are there. If you are writing program for this cos x and sin x and you don't know up to how many terms you need to write the program, then you won't be able to write the program. So how do we write the program for this? So better to divide all these things into function. Like if I'm going to call a function main, integer main is written, okay, followed by our functions are, these functions are already there, and I am using integer value or float value. Better to write float value so that it is very helpful for you. But in some contexts you need to use yes, integer also. So let us write each and everything, and then I am writing program. So here you can find that what is the pattern? What is the pattern? 1, 4, this is 1 and 4 and 8. These powers are positive. Similarly, negative powers are 2, 6, and 10. Yes or no? If you see, if you see on cos series, then you can see that these are the positive powers and these are the negative powers. So how do we write this function? So let us write a for loop. For loop will start from 0 or 1 for I equals to 1. Let us start with 1. 2 to the power 0 is 1. So it must start with 0. Okay. Then I is less than or equals to that number and I plus plus. Now, here I am putting one variable I, then sum equals to 0. Okay, so but this sum must be floating point value. So let me erase this. Yes. Just see the logic. I am not creating any program. Okay, this is not a program. This is just logic. So sum equals to 0.0. Then come here. And I had not put any semicolon here because I don't know how many variables it requires. Let us write this program. So for positive power, sum equals to sum plus what I need to write, power of x comma I divided by factorial of I. Yes or no? Minus, see, if I am writing this, then it is not giving, it is not providing correct output. So let us write the iteration in correct fashion. Okay, because I am having flexibility, I can erase the things, but you cannot. Otherwise, your program looks like this 0. Okay, I plus equals to 4. Each iteration you can see that the difference between positive to positive is 4 and negative to negative is also 4. Okay, here also 4, here also 4. Now minus power of x comma I 0 plus 1 is 2, I plus 2. Okay, then factorial I plus 2. And finally, this is power, this is negative power. Okay, now this will be our for loop. For loop is executed correctly. Then if you want to print the series, then you can use, you must have to write here what you need to write, printf %f plus, because each and every time you need to put plus after this. Okay, so I had written plus here, and in last term plus will automatically appear for one more term, comma, then it will start writing what it will start writing, sum for each and every iteration. Okay, and then this loop will be closed and it will return 0. And finally, this program will close. Here you can see that we have used two functions, power and factorial. Okay, power and factorial. It will automatically modularize the program. It will divide the program. If you write this program, can you imagine how many number of lines of code is required? Maybe 100 or maybe 200, because it is not very clear that up to what term we need to calculate the power, up to what term we need to calculate the factorial. So maybe some fellow are able to write the program in 50 lines of code, in 48 or 50 lines of code, but not less than these. Okay, but here you can see that this program is very simple, x to the power I. Okay, x to the power I. So what is the initial power? What initial power? Let us break for each and every loop. Suppose my loop will start from 0. So what is here? Sum is given, no problem. Power, power x to the power I. X to the power I is, what is the value of I? Initial value of I is 0.
0.
Okay, divided by factorial I, factorial 0. What is the value of this? 1. No problem. Now come to next. It is not plus, it is minus. Automatically the equation gives you answer in minus. So let us write minus. I had written minus. Okay, in the same loop, what is written here? Power x to the power I plus 2. So x to the power I is 0, 0 plus 2 is 2, and factorial 2. Okay, then come to next iteration will start. Next iteration will start means the value of I become 4. So this will be x to the power 4 divided by factorial 4 minus, this will be your x to the power 4 plus 2, that is 6 divided by factorial 6. and so on up to nth term. Okay, so this is the way you can write us. You can divide the functions, and it is very easily manageable. So in this program, are you able to understand what are the things and how it is executing the program? Is it clear to all of you?
Sir.
Yes. Yes or no?
सर इसके अलावा
Yes, sir.
फैक्टर और पावर भी हमको डिफाइन करने पड़ेंगे ना,
क्या चीज?
फैक्टोरियल पावर वाले फंक्शन।
फैक्टोरियल पावर वाला फंक्शन ये तो लिखना पड़ेगा। मैंने कहा बोला कि पूरा प्रोग्राम है। अभी तो इसमें x क्या है आपको पता है क्या?
नहीं सर।
You don't know x. I had not written any statement corresponding to x. Otherwise, I need to use one more variable, that is x. Okay. And what I need to write here, printf, one statement. Okay. And next statement is scanf.
Yes,
Fine.
sir.
Similarly, one more, up to how many terms? Up to, there is one more thing. So I had not written, I just want to show that how modular program is beneficial for you. Okay.
Okay, sir.
So this is, I had not explained any concept of function. I had just explained very little concept of function, that if you use function, then it is very helpful for us. Yes or no? You can create your own function. So this strategy, you are dividing your functions in many, means for each and every time, for this much portion you need to write one program, this much portion you need to write another line of step, another line of step. So better to write, or better to break, or better to divide it in sorry sorry better to divide it in function. So that's why it is known as divide. Okay. So is it clear to all of you? What is divide and
Yes, sir.
conquer? Okay.
Sir,
Yes.
sir, what is the meaning of %f plus?
Okay. This %f plus. Okay. Let me show you the output. It is very simple thing. There is no meaning of this. Actually, it is plus for one step and minus for another step. So it will give you output in plus and minus. So what happened? This term will executed, yes or no? The person who is having doubt, please confirm.
Yes, sir.
Okay. So in step 1, some value of sum is coming. Let us say x. Fine. So this, let us not say x. It is 9.2, suppose, in first step. Fine. So this will replace by this 9.2, and then automatically it will use the plus. And in second step, suppose this value is 6.3. So this is replaced by 6.3. In third step, the value may be, so automatically 6.3 plus. So this plus is like this. In suppose is in some step, the answer is minus, this plus is appearing, and suppose the answer is minus 6.323. Okay, so automatically plus will be printed because I had given plus, and this minus is also printed, and then again plus will be printed. So this is just to print the plus, and it shows how many step and different steps, different output of different step. Clear?
Okay, sir. Thank you.
So likewise, you can also create the program you can create a prototypal program for sine series. Yes or no?
सर एक डाउट था सर.
Yes.
सर हम सम की जो वैल्यू है वो हर बार बढ़ती जाएगी और जो फाइनल वैल्यू आएगी वो आंसर होगा ना कॉस्ट का.
Yes.
तो सर जब हम उसको बार बार प्रिंट करते जाएंगे तो वैल्यू वो मतलब
गलत
क्लोजर
आएगा.
आती जाएगी.
सही बोल रहे हो, बिल्कुल सही है, एकदम सही है. इंक्रीमेंटल वैल्यू दे रहा है एंड फाइनली इट विल प्रिंट द आउटपुट. सो वी नीड टू यूज अनदर वेरिएबल फॉर ईच स्टेप.
यस सर.
Maybe this is sum1, okay, and sum equals to sum plus लिख रहे हैं, that is good, but each step is having different output. Correct. So in this program it will not work. Okay, this line will not work. Otherwise, if I had written sum, then I need to create one more variable, that is sum1. Okay, and then I need to use this sum1, and this sum1 is equals to 0 actually. Okay, and there is no meaning of this sum. I need to discard this sum and I need to use the sum as sum1 equals to sum1 plus sum. And now I think it is correct. Yes. Agree?
Yes sir.
With only one line of addition, it will give you correct answer, and there is no need to initialize sum equals to 0. Correct? And that is great thing, because yes, it is always giving you incremental value or some decremental value depending on output. Obviously, it will give you incremental value. So construct a program. Yes.
सर प्रिंट ऐप में भी तो सम होगा.
नहीं, प्रिंट ऐप में सम आएगा क्योंकि आप सीरीज शो कर रहे हो, इसलिए तो ये प्रोग्राम चेंज किया, इसलिए तो ये लाइन चेंज हुई है. यदि मैंने यहाँ सम 1 लिख दिया तो पुराने प्रोग्राम और नए प्रोग्राम में कोई अंतर ही नहीं रहेगा. ठीक है, आप करके देखना, आपको खुद समझ में आ जाएगा. अभी तो हमने शुरू किया है ना, एक छोटा सा प्रोग्राम. So what divide and conquer strategy says, construct a program from a smaller piece or components. Our pieces are power and factorial. These smaller pieces are called modules. So this is power module and this is factorial module. Each piece more manageable than original program. So I had already told you that if you are going to write program for this particular thing, you will not be able to run this program, or you will not able to run this program in 48 steps also. Okay, so this is very tricky. Just try to create a program because I am not interested to create. So you just try to create without function. Okay, without using power function and without using factorial function. Just try to create a program. Then you will be able to understand that how this program is very lengthy. Not tough, but lengthy. Program modules in C. Functions. Functions are modules in C. Program combine user-defined function with library functions. You can write your own function. Okay. C standard library has a wide variety of function. Function calls. Function calls means here this power function is function call. Now let us define power function. What is the use? What is power function? So power will return floating point value. Let us write float, and the name of function is power, and the arguments required, 2 arguments are required, and both the arguments, not necessarily one argument may be float or may be integer. So let us write float x comma integer I. This must be integer. Okay, because for loop is not able to run in floating point values. Now what it will return? power will return for, and initially one more value is required, not integer, it must be float. Float sum. So for integer I equals to 0, I is less than, okay, if I am passing I, this number must be n. So many modifications it require whenever you are writing program. You cannot clearly write the program initially. So be careful, just write it in I is less than or equals to. So this program must start execution from loop number 1. So it must start execution from loop number 1. I is less than or equals to n, and then I plus plus. Okay. And what is the value of sum? Sum equals to, actually it is product. Sum equals to sum multiplied by x. So this must be initialized with 1. Okay. Sum must be initialized with 1. So 1 multiplied by anything is whatever value of this. And then it will return. I had written sum, but it must be product. Okay, you can write anything x, y, z. So this will return, finally return sum, and this program will return sum. So each time whenever power function will be called, it will automatically run these many steps and it will give you output. Okay, so this is example of power function, and now I will show you example of factorial function. Factorial function, I am writing long factorial because it is integer value, integer n. Okay, now what is the initial value of factorial? Fact equals to 1. Integer fact equals to 1. Okay. If the value is 0, then factorial value of factorial must be 1. So then integer fact equals to 1. Any other thing it requires? No. For, and this must be fact 1. Actually factorial is the name, so both the names must be different. So for integer I equals to 2, I is less than or equals to n, I plus plus. Okay, and then it will return fact 1 equals to fact 1 multiplied by I, and then it will return fact 1. Any doubt?
No, sir.
Fine. So these are the two functions, but if you write in a program without any function, then it is very, very difficult to understand the program. So this is how modular programming will work. You need not to write these two functions for each and every value. It will automatically get used. Then this is function call. So whenever I am calling power function, it will automatically substitute it to this function and it will return some value, and the return value will be coming here because this function is of float type. Okay. Provide function name as and arguments. Function performs operation or manipulation. Function returns result, and function call analogy, like boss asks worker to complete the task. Okay, worker gets information, does the task, and return the result. Information hiding, boss does not know how worker has performed the task. Similarly, here also, how this worker has performed the task, we don't know. This is our boss and these are two servants. One servant perform power and another servant perform factorial. Fine. So let us now discuss some math library function. Math library functions are inbuilt function and you need to include math.h. These are common mathematical, these performs common mathematical calculation, and format for calling function is function name followed by argument. Like here, square root of 900. Okay, sqrt 900. So it will automatically return some value and this value will be printed in how many precision value? 0.2. Means suppose some value is like 0.48967. Suppose this is our answer, then it will print 2.49. Okay, this will be the final answer. So this %2f will says that up to 2 places. This 2 means up to %.2f means up to 2 floating point places. Up to 2 floating point places or decimal places. Arguments may be constant, like here we have used constant. Variable like square root of x, sqrt of x. Here in previous example also we have sent the variables. Okay, we have sent the variable. So likewise you can pass the argument as variable also. Or expressions means the same power function. You can write power of x, okay, comma power of x comma 2. What is the meaning of this? It simply means that x to the power x comma 2. It means x to the power 2. This is the answer. Okay, it will return this value. So functions modularize the program. All variables declared inside functions are local variables. You cannot access these variables outside the function, known only in function defined. So here the sum, this sum is different from this sum, whatever sum here used. Although it is used in the same program, because if we call, then another sum will be called, but this sum and this sum has different value. Okay, both are not same. All variables declared inside functions are local variables, known only in function defined. Its scope is local. Parameters. Suppose a function is, suppose power function is given. So what are the parameters? Integer x comma integer n, x to the power n. Okay, this will return what value? Return x to the power n. Just I had and this long kind of value. Okay, so parameter communicates information between function. So if this parameter is for message passing, you can also say that this is message passing. Local variables already there. Benefit of function, it is divide and conquer, manageable program development. Multiple times you can call this. Software usability, you can use this function in different places. Use existing function as a building block for new programs. Abstraction, hide internal detail. So this function hides the internal detail. Okay, avoid code repetition. So code repetition is also avoided by this function. So till now, if you have any doubt, you can ask. No doubt?
No doubt, sir.
Okay, so let us see how function will be created and how it will be used. Okay, so let me explain you first program. This is our power function. This is our first function. Okay. If you want to see, I'm not going to explain you sine series. Let us start very simple program. Integer main. Nothing will be given here. Just to test whether power is working correctly or not. Integer x equals to 5 or x equals to 2. Fine. For don't write for printf %d %ld because long function is given, comma 2 to the power 2 comma 5. 2 to the power 5 is 32. Yes or no? So if answer is coming 32, then our program is correct. Otherwise it is return 0. Let's run this program. So the answer is 32. Yes or no?
Yes, sir.
So power function is correctly written. It means agree or not?
Yes, sir.
If you are not agree, then ask the question. If you are agree, then I will move forward. Let us now create
सर
a
नहीं समझ
function.
आया सर.
पावर फंक्शन नहीं समझ में आया. कहाँ नहीं समझ में आया बताइए. लाइन नंबर बताइए.
सर लास्ट का नहीं सर, शुरू का तो आ गया, लास्ट में पता नहीं क्या समझ नहीं आया सर.
ये वाला ये
हाँ जी
पोर्शन ही.
सर.
हाँ, यहाँ पर क्या है, हमने फंक्शन को कॉल किया है और फंक्शन क्या है, हमारा पावर है. ये देखो, ये पावर फंक्शन है. पावर फंक्शन में हमने क्या वैल्यू पास की, 2. तो 2 विल बी ऑटोमेटिकली. सो लेट मी डेमोन्स्ट्रेट दिस फंक्शन मच बेटर. ओके, हाउ दिस इज executed. So because it is very important, and once you have practice of writing function, then you can write anything. The codes are very simple. So this is our function. Okay. Oh yes, control C and then control V. Another portion, format crop. This is our power function written here, and this is our main function, crop. This is our main function. Okay, I want to write a function which will print the power. Okay. So each C program will start executing from main program. Okay. From main program. Yes or no? So what is the initial value of X? Initial value of X is 2, integer type. And now I want to print power. So this will print power function. The compiler will check whether power function will exist or not. It is there. Okay. Now what is the value passed here? So in place of X, you can pass 2. In place of N, it is 5. Okay. Now what calculation will done here? So here X equals to 2 and N equals to 5 and prod equals to 1. Now this for loop will run from 1 to n times. 1 to n times means 1, 2, 3, 4, 5 because the value of n is 5. Now what will be calculated here? Product equal to product multiplied by X. So it will calculate this value. Product equals to this will calculate product equals to product multiplied by 1. Initial value of product is 1 multiplied by 1 equals to 1. Then this 1 multiplied by, but here I had written X. So what is the value of X? Value of X is 2. Okay, so this will be 2. Now come to 2. Please mute yourself. 2 multiplied by X. What is the value of X? 2. This will be 4. In third loop, this 4 multiplied by 2. Sorry. In first loop, this will be answer. In second loop, in third loop, it will be 8. In fourth loop, 8 multiplied by 2 will give you 16. And in fifth loop, 16 multiplied by 2 will give you 32. And this will be the final answer. Now this product will be returned. This product will return to. So what is the value? This is 32. This 32 will return back to here and it will print 32. Okay. So any doubt in function calling? Is it clear to you?
Yes, sir.
The girl who has some doubt. Is it clear to her?
Yes, sir, it is clear, sir. Thank you, sir.
Okay. So likewise, we can create our own function. Okay. Suppose now I think time is almost over. So I will better to create one more function and just try to understand it. Now next function is long factorial. Because the value returned by factorial is very long factorial, and the parameters inside only factorial of n will be calculated. So that's why single parameter is sufficient. Okay, power is written in terms of x to the power y. That's why x and n is given. Now, what is the value? Here also I am using integer n, but this integer in n is available to factorial function. Okay, now come to integer. Is integer is required? No, long is required. Long f equals to 1. Then come to for integer I equals to 2. Why I am starting from 2? Because there is no meaning of multiplied by 1. Okay, that's why I am starting from 2. I is less than or equals to n and I plus plus. Now f equals to f multiplied by I. And then finally it will return f. Okay, so let us check for factorial also, whether it will give us factorial value of factorial correctly or not. So LD is written for long double. And this is our factorial 5. Factorial 5 is 120. So this will give you 3 to 120, correct? Because I had not written slash n, so better to write slash n. Now, yes. So 120 is coming. Means answer is correct, but accidentally it may be correct for this value. So let us check some other value also. So for 7, it is also giving correct. So up to this point, we have created two functions and we will use all these. Another thing, now we need to create sine function also. Okay, sine series function. So tomorrow I will show you both the variation. One variation we create in one variation we will create sine function, and in another variation without creating sine function we will run the program. Okay, so fine. Any doubt till now? You have recordings also by evening, so please try to call back all these things, recall all these things, and if you have any doubt, if you feel that in any point there is difficulty, so please ask. Okay, so I had downloaded the attendance list also. So with this we finish our recording.